The idea of understanding water trail is related to the ability to see one's surroundings as part of a larger system. It is the nature of water to keep flowing, from the mountain tops to the plains to the seas and the oceans, from the clouds to the ground and then deep beneath the earth's surface. Your school campus is also a part of this system.
One of the things we'll try and do here is to find out the sources of water for the school. We call it the water trail. We'll find out the borewell from where the water is coming, and then we'll try and trace the path it takes for various consumption, for all the use that happens, and then what happens to the water once it is used. When we were looking at the source in the school, we found one borewell from groundwater and rainwater harvesting as the only sources. In other schools, we may find that water comes from municipal lines. It may come through private water tankers. Some schools may get water from open wells, and some schools may have to bring it in buckets and other utensils. So the school will have to look at all possible sources of water and map them as part of the exercise. One of the questions that I had for you is that you mentioned to me that the borewell is the source of water for the school, right? But what is the ultimate source of water for the borewell too? Groundwater is the source for borewell. But what is the source for groundwater? Aha, that's the only source of water for the whole of India. Rainwater. Rain is the primary source of water. How do we start to understand how much rainwater falls on this campus? Yeah, brilliant. So how do we make a rain gauge?
Basically, you take a glass with straight sides. So it has to be straight because
because when you're taking the measurement, you'll take it in the height. So if it's narrow at one point, then the water will rise.
Okay,
so it
and
has to
then?
be constant. So what we made was a
Very simple.
very simple one.
Simple one, and it didn't go out. Right?
It didn't. We'll see. So basically, we took a glass jar with straight sides, and we took a scale, and we just taped the scale onto the glass jar, or you can mark the
Mark
reading.
it, yeah.
It doesn't
And
matter.
then, so we had two groups, and one of them marked.
And we did the taping of the scale, and then we took a plastic bottle.
Yeah, and we took the conical part of the bottle and we cut that, and we attached it to the mouth of the glass jar.
So to make a funnel sort
Yeah,
of
to make a funnel, so when it rains, the water doesn't fall on the sides of the jar.
and so it all collected and comes into one. And then
Yeah, that's
we
pretty
took
much
it and put it on the terrace because we didn't want any obstacles, because obstructions, and because if you put it right next to a wall, if the rain is coming on the other side, you won't get the water. So it has to be free from everything. So we did that.
Now, once you make a rain gauge, what is the reading taken in? Millimeters. Perfect. If you measure the school area in square meters, the area of the school in square meters, and you have the rainfall in millimeters, if you multiply the two, you get the liters volume of water falling on the school campus, right? It's a very simple device, very simple way of measuring it. We'll do that. We'll do the rain gauge and we'll measure it. What do we have here?
Rain gauge.
And what does a rain gauge do?
Measures the rainfall.
And the unit of measurement is?
Millimeters.
Great. So we also have a roof here which is pretty clean. The roof becomes the catchment to collect rainwater. If we take the square meter roof area and multiply it by the millimeter of rainfall, you would normally get the volume of rainwater that we can collect in liters. So suppose this roof area is 100 square meters and it rains 10 millimeters. How much rainwater are we grabbing in that particular area? 1,000 liters, right? So in an average year of rainfall in Bangalore, you can capture up to 90,000 liters per 100 square meter. That's quite a substantial amount of rain. A simple way to catch rainwater is using this drum called the rain barrel. How big is this rain barrel here?
5,000 liters.
How much does it weigh?
5,000.
Ah, perfect. You're learning fast. Okay. Now, in a good year of rain, it rains over 60 rainy days in Bangalore. If we empty this rain barrel every time it rains, it will fill up 60 times. How much water do we grab then?
3 lakh liters.
What did you calculate your daily water demand as?
7,500 is calculation estimate.
So 7,500 liters. You estimated it as that, right?
Yeah.
How many days of water demand would this rain barrel serve?
About 200 days.
About 200 days?
Yeah.
That's a substantive amount of your water demand coming from one roof and one rain barrel. If schools plan and manage their rainwater better, they can meet a lot of their water demand from rain alone. It's up to us to ensure that the quantity is good and the quality is good. Do you agree?
Yes.
Do you Good.
That was too enthusiastic.
Okay, I've been talking to Shekhar here, who's in charge of the borewell and the pump here, and he's been telling me some things. He's telling me that there's a borewell inside, and the borewell is about 300 feet deep. Did you know that this was around in your school?
No notice.
And do you know how long this borewell runs in a day?
No.
He was telling me that it runs for 12 hours.
It's a long time.
And you'd be curious how much water it pumps out in an hour, right?
Yes, you're going to ask that?
Right. So it pumps out about 4,000 liters of water every hour.
Oh my god, that's huge amount. So it is 48,000 liters a day.
Perfect. 48,000 liters of water every day comes from this borewell, and this is the only source of water. That's what Shekhar tells me.
So is all the water used or it's stored?
By the school, or is it stored somewhere?
Well, this borewell and the 48,000 liters of water is for the school and for the 4 houses here, as well as for the garden and the farm which grows vegetables. A lot of the water goes for the vegetables too.
So it's all used then?
It's all used. And remember, this is the only single source of water for the school, this borewell. Right?
Yeah.
ठीक बोला शेखर?
ठीक है सर.
हाँ.
The water that comes from the dining hall and the water which is from the kitchen wash area, all of that has merged and is collected here in this gutter. We have a sieve here, a fine metal sieve, where any solid particles that have by chance come into the water are removed completely on the sieve. So the water that goes into the pit for the grey water is very clear, is devoid of any solids or fats, whatever possible we do removal in this from the sea.
So, what's this beautiful thing here?
Actually, what happens is another source of the waste is the waste water from the canteen and the kitchen. That water is purified through different stages, and it finally ends up here. This water is purified using sieves, and then after that it's purified using these stones and plants until it's made into quite pure grey water, and then it's quite clear grey water, and then it's transported through pipes underground and it goes over there.
Okay, let's go and see where the grey water ends up, shall we?
Yeah. So the treated grey water from there comes to this collection pit through a pipe. Let's see what happens here.
This water is pumped through a pipe to the garden where it is used to water various plants and vegetables.
And we seem to have come to a very interesting place. What's this?
This is the sewage pit, and it's one of the places where wastewater ends up. And so basically, the water from the toilets comes in, accumulates in the sewage pit.
Right, and a lot of it seems to soak away into the earth, the liquid portion of it, right?
Yeah.
Yeah. What would have happened if you were in the middle of a city? What would have happened to the toilet water then?
It would have been connected to sewage drains, to the pipes, which would be only in the city. And because we're in a school campus, we don't have pipes around.
Okay, so that is called off-site sanitation when it is connected to a sewerage drain. This would be what we would call in engineering on-plot sanitation. So on the plot or on the site, we are taking care of all the wastewater from the toilet, allowing it to accumulate in one place, soak into the groundwater. We should be careful that it does not pollute the groundwater. We should maintain a distance between this pit and the borewell or the open well that we have. Typically the distance is about 8 meters. And this, what happens when it gets full?
There's a truck which comes and it sucks up all the waste and then goes.
Perfect. That's called in funny language a honeysucker. The honeysucker comes and sucks out the honey from this. And if it's well maintained, the honey is then composted so that it can be used as a fertilizer in farming fields.